Hello class, in this lesson we are going to look at multiplying rational expressions. Now if you remember rational expressions, these are expressions that look like fractions. They just have a variable in the denominator, right? And they look like fractions, they act like fractions. We multiply these exactly the same way we would multiply fractions. So if we had a fraction, a over b times c over d, you just multiply straight across. A times c, b times d. And then you'd simplify it if you can. Right? So here we have 5x squared over 2xy squared times 6xy cubed over 10y. You just multiply straight across. 5 times 6 is 30. X squared times x is x cubed, and then y cubed. 2 times 10 is 20. X, there's no x's, so just x. And y squared times y is y cubed. Right? But then we need to simplify this. So we just simplify it one bit at a time. Simplify your coefficients in the front. So 30 over 20, that would be 3 over 2. It's got a common 10 as a factor, so that factors out. X cubed over x, that has its common x we can factor out, leaving with x squared. And then y cubed over y cubed cancels out. You're just left with 3x squared over 2. Now, as we saw in the previous video on simplifying, if you factor something out of the denominator, you still have to say that that factor cannot equal 0, right? So we factored out an x, and we factored out some y's. So we need to say that x can't equal 0, and we need to say that y can't equal 0. Because remember, nothing in the denominator can multiply to equal 0. Right? All of these factors have to be 0, because it cannot be 0 because we cannot divide by 0. And this is supposed to be the exact same thing as this over here, right? So if this couldn't have an x equaling 0, our simplified form also can't have x equals 0. So we have to say that x can't equal 0. We also have to say that y can't equal 0, because y cubed would have this whole thing divided by 0, which cannot happen. All right. So let's take a look at one of these. We're going to multiply 8x cubed y over 2xy squared times 7x to the fourth y cubed over 4y. All right. So just like a fraction, you multiply straight across. 8 times 7 is 56. X cubed times x to the fourth is x to the 7th. Y times y cubed is y to the 4th. 2 times 4 is 8. X, there's no x's here, so just x. Y squared times y is y cubed. Now we want to simplify this as if we can. And yeah, this will simplify. So 56 over 8, 56. The 8 cancels out, they're both divisible by 8, so this leaves you with 7, no coefficients in the denominator. X to the 7th divided by x is x to the 6th. Y to the 4th over y cubed just leaves you with 1y, right? Y to the 1st. Those get factored out, so you're left with 7x to the 6th times y, right? That's all you're left with. Now, we factor the x and y out of the denominator, so we have to say that x and y can't equal 0. Right? Don't forget that. Whatever you factor out of the denominator, you have to still say that those cannot equal 0. Okay? So this one was fairly simple. This one's a bit more complicated because you have other things on here. It's just not a single term. We're not multiplying monomials. We're multiplying polynomials. So 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. So what we're going to do is we multiply. Well, things that can help this is factor it. Before you go to multiplying them out, factor them. All right. So 3x minus 3x squared factors as 3x times 1 minus x, right? Because you can factor 3x out of both of these. Our denominator here, factor this out, you have x minus 1 times x plus 5. In the numerator for the other fraction here, the rational expression factors is x plus 5 times x minus 4, and then 3x is 3x. Okay? Now, we multiply straight across, so we take all of these times all of those, right? Or we can just list them all there next to each other. We don't want to actually pull all these together, because then we're going to have to factor them anyways to see if they have any common factors. So don't bother with foiling this all together and doing all that double distribution and putting it in the box and all of that stuff. Don't mess with it. Just take them, they'll all be multiplied, so you can just list them all straight out together. There it is. Now we're going to simplify this. So what do the numerators and denominators have in common? Well, if you look, they both have a 3x. They both have an x plus 5. We got this x minus 4, which don't have it. Now here you have x minus 1 and 1 minus x. Those look really close together, right? Not the same thing. They have an x and a 1, but here the x is negative, here it's positive, here the 1 is positive, there it's negative. If all you're doing here is changing signs, what you can do there is factor a negative 1 out right here, and now they're the same. Because when you factor a negative 1, it changes the sign. So your negative x becomes a positive x, your positive 1 becomes a negative 1. Now these are the same. So any factors that are the same get canceled out. So that would be the 3x, the x minus 1, and the x plus 5, right? Those get factored out. Well, you divide it from the numerator and the denominator. Leaves you with a negative 1 and x minus 4. So you go ahead and distribute that in. You have negative x plus 4. Now, we factored a lot of stuff out. And so we have to say that each one of those things that gets factored out cannot equal 0. So x minus 1 can't equal 0, which means x can't equal 1. X plus 5 can't equal 0, so x can't equal negative 5. 3x can't equal 0, so x can't equal 0. All right? You have to say that for each thing. And check these in your calculator to make sure that you have those. If you take the original expression, just type it in just like this, into your y equals on your calculator, and you take your simplified negative x plus 4 and type that into your calculator, you notice that the numbers come out the same except for these three values here. Right? In the original, we have errors because we had zeros there, and you can't divide by 0. But in the simplified form, that's not an issue, right? Because in simplified form, this is linear, and it goes forever. It's all real numbers, right? But the original is not linear, like this one is. It's got holes in it. It's basically what these are. These are called point discontinuities, and it's just a little hole in the graph. All right. And so, since they're not in the original, they can't be in the simplified form either. Alright, because the simplified form is supposed to be a simplified form of the original, so it should look just like the original when you graph it. And if you leave these 3 points in there, then it doesn't look like the original, because the original has holes in it, and the simplified form does not. Right? So anything that you factor out, you have to make sure that it will not equal 0. Okay. Alright, let's take a look at this one. Here we have x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. All right, we're going to multiply this straight across. You don't multiply both of these times that. Remember, this is over 1, right? So you set it over 1, like that. Now you can multiply straight across. Now you want to go ahead and factor it first, because that makes it easier. And the denominator here, notice these are perfect cubes. So we have difference of cubes factors like so. This doesn't factor, so we leave it like this. Oh, and look at there. We have x squared plus 3x plus 9 in both numerator and denominator, so we can factor that out, which leaves us with x plus 2 over x minus 3. Now notice it didn't say something x can't equal some number, and the reason for that is that this, as long as x is a real number, will never equal 0. And so since this won't ever equal 0, we don't have to say, hey, it can't equal this, because it doesn't have anything that will equal 0. Yeah? So if you multiply by something like this, make sure you set it over 1, and then you can multiply straight across just like you did before. Yeah? Okay, so what I want you to do is work out these three problems here. Pause the video, work them out to get your answer, then come back and check your work. Alright, let's see how you did. Number 5, you should have had x squared y squared over 4, where x doesn't equal 0 and y doesn't equal 0. For number 6, you should have had x plus 3 over x times x plus 5, where x can't equal 5. And on number 7, you should end up with x plus 5 over x minus 1. Right. If you got those, great. You got this down. You're done with the video. You don't need me anymore, at least not for this. If you didn't get this, let's see why. All right. So number 5. So here's our original problem. We're just going to multiply them straight across. So 3 times 6 is 18. X to the 5th times x is x to the 6th. y squared times y squared is y to the fourth. 8 times 9 is 72. X times x cubed is x to the fourth. Y times y is y squared. And then we simplify. So 18 over 72 is 1/4. So we have 4 over down there. The factor of the 18 out of both of those. X to the 6th over x to the 4th is x squared. And y to the 4th divided by y squared is y squared. There's that. Now remember, we factored this x out. We factored some y's out of the denominator. Those both came out. And so x can't equal 0. Y can't equal 0. On number 6, here's our original. Go ahead and factor it first. Anytime you have polynomials, factor them before you start multiplying. So we factor the 2x squared minus 10x as 2x times x minus 5. We factor the x squared minus 25 as x plus 5 times x minus 5. These both don't factor. They're already simplified. So what do we have in common? Well, you got an x minus 5 and an x minus 5. You have 2 x's here and you have 2x squared here. So you can take one of these x's out. All right. Take the 2 out. You can take one of the x's out. You can take the x minus 5 out. That leaves you with the x plus 3 here, the x plus 5 there, and that other x from the x squared. All right. So you have x plus 3 over x times x plus 5. Now, we did take the x minus 5 out, so we've got to make sure that does not equal 0, so x can't equal 5. All right. Number 7, we have this. I'm going to set this over 1, so there it is over 1. Factor the x cubed minus 1. This is a perfect cube. Well, not a perfect cube. This is difference of cubes, sorry. And so that factors as x minus 1 times x squared plus x plus 1. And those two are the same, so those get factored out, and multiplying by 1 doesn't do anything, so we can ignore that. And that just leaves us with the x plus 5 and the x minus 1. Now, we would set this equal to 0, so it doesn't equal anything, but it doesn't work. It'd be imaginary, so we don't have to worry about saying it can't equal anything. And that is multiplying with rational expressions. It works just like fractions, but it's a little bit more complicated than that. But it works the same way. All right? You're going to multiply straight across and then simplify, factor out any common factors. All right? So, always factor it first. If you have binomials, factor that stuff before you start multiplying. All right? Don't try to FOIL anything together. There's no point to that because you're just going to be factoring stuff out again later. So don't try to FOIL anything together. Factor it out. Then basically you're just going to list out all your factors. Cancel out anything that the numerator and denominator have in common. And make sure that that does not equal 0. Okay? Hopefully that helps. And I'll see you next time.